Okay, so now we want to map 3 or more genes. We follow the transmission of 3 genes, one that codes for the color of the body, one that codes for the color of the eyes, and another one that codes for the wings. So in order to find the distance between those genes, we need to first have a heterozygous individual. If you don't remember why, please go back to the first tutorial. We will cross them with a homozygous recessive individual, in other words, a test cross. Then all the offspring will show in their phenotype directly the type of gamete made by their parents. So the test cross will help us to reveal the gametes of the F1 individual. Most of them will be of the parental types. So most of them will be transmitting like all 3 recessive or all 3 dominant alleles at the same time. But we will also see all sorts of combinations of alleles that result from the crossing overs occurring between those 2 homologous chromosomes. So anything that is not a parental type, so anything that doesn't have the 3 recessive or the 3 dominant alleles together, is not a parental and should be counted as a recombinant. So, as we said, the test cross will reveal the gametes of the F1. We will first identify the parental type and the recombinant types by gene pairs. So we will take 2 genes at a time and then look at the parentals and recombinants. So let's say we look at the gene B and PR first. The parental types are BPR, so recessive, or B plus PR plus, so both dominant. And the recombinants are anything that have a reshuffling, so B and PR plus, or B plus and PR. So if we look at now the next gene pair, so the PR and VG, the parental types are when you have both dominant or both recessive alleles, and the recombinant types are the ones where you have a reshuffling, PR and VG plus, or PR plus and VG. Finally, the third pair of genes is B and VG. Parental types are B and VG together, or B plus and VG plus together, while the recombinants are B and VG plus, or B plus and VG. So we will first do the percentage of recombinants between B and PR. So if we look at the parental first, the B plus and PR plus are all these individuals that have gray bodies and red eyes. And the other parental type is brown body and the purple eyes. Now, the recombinant types, gray body and the purple, or brown body and red eyes. Let's now count the parentals. We have 411, 61, 60, and 412, which makes a total of 944. Now, if we count the recombinant types, 2 plus 30 plus 28 plus 1, which makes a total of 61. Now, the percentage is just easily the count of 61 divided by the total of recombinant and parentals. So it will give us a frequency of 0.06 or a percentage of 6%. So it gives us a distance of 6 centimorgans between B and PR. Now we do the same thing with the next pair of genes. So let's erase all this and start over with now the second pair of genes, which is PR and VG. And now let's count the parentals, which are PRVG, so the purple eyes and vestigial wings, or the other parental type are those with red eyes and normal wings. So we have 411 and 28. Now the recombinants for that gene pair are the purple eyes with the normal wings or the red eyes with the vestigial wings. So we have 2 and 60 and 61 and 1. So we have 124 divided by the total of individuals. So it gives us a frequency of 123, so 2.3% of recombinance, or 2.3 centimorgans. And next we do it with the last pair, so between B and VG. So same idea, we do the parental types, brown body and vestigial wings, or gray body and normal wings. And now we do the recombinants, so all the ones that have brown body and normal wings that we didn't have in the parents, or the gray body and the vestigial wings that we also didn't have in the parents, we will obtain a percent of recombination of 179 divided by the total number of flies, which is 1005. So the frequency of recombination is 0.178, so 17.8%, or 17.8 centimorgans of distance between the two genes. So with this, we can order the genes. So when we want to order the genes, one thing we have to first find out is the gene that is potentially in the middle. The least frequent recombinants usually correspond to the ones that have had a double crossing over. If you don't quite get why, I will refer you to the other tutorial where we do the mapping. Here, the least frequent individuals are the ones with body color and the wings as parentals, but the eye color gene is not a match. So the gene encoding eye color is located in between the body color and the wings. So we will first put the eye color in the middle, the body color at 6 centimorgan, the wing at 12.3 centimorgans, and we have a distance between the body color and the wings of 17.8%. Now, one thing that is a little bit annoying in that is if you look at the distance between the body and the eye color, or the eye color and the wings, you should obtain 18.3 centimorgans and not 17.8. However, since they did two recombinations, those individuals that were counted in the parentals were the result of two crossing overs. So when we calculated the distance between B and VG, those individuals were identified as parentals, but in fact they should have been identified as double recombinants. So the real proportion of recombinants is what we had before, so the 179, some plus 2 times the 3 recombinant types that are known to have had a double recombination. So if we do the total of that, it will give us a new recombination frequency of 0.184, which is 18.4%, or 18.4 centimorgans. So if we look at what we had before and we redo the map, we can now refine the map with the recalculated distance that take into account the double recombinants that were previously counted as parentals.